India's Chandrayaan-3 mission made history. It placed India among the select few, the fourth nation ever to successfully land on the moon. Even more impressively, it became the first to touch down near the lunar South Pole, a region so cold and shadowed that sunlight hasn't reached some of its craters for billions of years. The lander, Vikram, and rover Pragyan achieved what many once thought impossible. They sent back data that deepened our understanding of the moon's chemistry and geology, providing clues that could one day help us live there. But what fascinates us most is not what Chandrayaan-3 found, it's what it didn't. Because this mission was sent to the very place we expected to find one thing above all else: water. And yet, there was none. So let's look closer, not just at what India achieved, but at what this mystery reveals about the moon itself. The moon's south pole has intrigued scientists for decades. If water exists anywhere on the moon, it would be there locked in craters so deep and cold that they never see direct sunlight. Temperatures inside these cold traps can fall below 200 degrees Celsius, making them some of the coldest known places in the solar system. Back in the 1960s, scientists had already begun to wonder whether these regions might hold frozen water. Later, during the Apollo missions, astronauts detected traces of hydrogen and water vapor, but never solid ice. The images we had were too dark, the instruments too limited. Hydrogen could mean water, or it could mean something else entirely. So the question remained unanswered until India decided to look again. In 2009, Chandrayaan-1 changed everything. Carrying NASA's Moon Mineralogy Mapper, it detected spectral signatures of water ice in dozens of craters clustered around the lunar poles. It was the first solid evidence that these shadows might indeed hide ancient ice. Its successor, Chandrayaan-2, confirmed these findings years later. Scientists estimated there could be as much as 600 million metric tons of frozen water waiting in those dark craters. If true, that water could one day sustain astronauts, provide oxygen, and even be converted into hydrogen fuel. So when Chandrayaan-3 launched, it carried not just instruments, but expectations. If it could find and analyze that ice directly on the surface, it would change the course of lunar exploration forever. Chandrayaan-3 launched on July 14, 2023, consisting of three main parts: the lander module Vikram, the rover Pragyan, and an orbiter that carried them from Earth to lunar orbit. After weeks of precise maneuvering on August 23rd, Vikram gently touched down near the moon's south pole, carrying Pragyan safely inside. For India, it was a proud moment, but time was against them. Unlike expensive NASA missions that can last for years, Chandrayaan-3 had a budget of just $75 million less than many Hollywood films about the moon. Its lander and rover weren't designed to survive the lunar night, where temperatures plunge to 122 degrees Celsius. They had exactly one lunar day, about 14 Earth days, to complete their mission before darkness fell. Every hour mattered. Once Vikram deployed its ramp, Pragyan rolled down to the dusty surface, a six-wheeled 27-kilogram explorer built for one purpose: to investigate the moon's composition. It carried two powerful instruments: the Alpha Particle X-ray Spectrometer, or APXS, bombarded lunar soil with radiation to identify its chemical elements, and the laser-induced breakdown spectroscopy system, or ELIPS-fired pulses of laser light, analysing the glow of the resulting plasma. Together, these tools could reveal what the moon's surface was truly made of, and perhaps detect hydrogen, the fingerprint of water. As Pragyan fired its instruments, data began streaming back to Earth. It detected aluminum, calcium, iron, chromium, and titanium, along with traces of oxygen and sulfur. The sulfur detection was especially important, the first ever found at the lunar south pole, hinting at past volcanic activity. But one element was missing: hydrogen, and with it, any sign of water. Pragyan moved slowly about 1 centimetre per second as it explored the uneven terrain. Each command from Earth took nearly 3 seconds to arrive, meaning every move had to be carefully planned. Early in its journey, the rover narrowly avoided a 4-metre crater that could have trapped it forever. It continued onward, scanning rocks and soil as it went. But despite its careful search, there were no icy glints, no frost, no sign of water, only endless dry lunar dust. By the time it had travelled roughly 100 metres from the lander, it was clear whatever water was supposed to be here, it wasn't on the surface. While Pragyan roamed Vikram itself wasn't idle. It carried its own instruments to measure the moon's environment. Using a temperature probe, it drilled 10 centimetres into the ground, recording the heat at different depths. It also studied the plasma environment, confirming that the moon's thin exosphere would cause almost no interference with future radio communications. Vikram even detected a small moonquake, adding new data to the study of lunar seismic activity. And in a final experiment near the end of its mission, it performed a short hop, firing its thrusters to lift itself about 40 centimetres off the surface and land a short distance away. It was a tiny leap for a robot, but an important test for future missions that might one day return to orbit. Still, none of these triumphs brought Chandrayaan-3 any closer to its original goal, finding water ice. By September 4th, the lunar day came to an end. Temperatures began to drop, and the sunlight that powered the mission faded away. ISRO, India's space agency, commanded both Vikram and Pragyan to power down in the hope that they might reawaken when the sun rose again. But when that dawn came, the two explorers remained silent. Their mission was over a success by every technical measure, yet shadowed by a scientific mystery. If water ice was really there, why hadn't they seen it? When we imagine water on the moon, we might picture thin layers of frost or glittering sheets of ice nestled in shadow, but the reality has been far less picturesque. NASA's ShadowCam, an ultra-sensitive camera aboard South Korea's Danuri orbiter, recently looked directly into the same polar craters, places untouched by sunlight for millions of years. And it too saw nothing. No gleaming ice, no frost, only dust and rock. It was the same with Chandrayaan-3. Every measurement confirmed a dry surface. So what happened? Had previous detections been wrong, or could the water simply be hiding where we can't see it? The answer might lie in one of Vikram's quietest experiments, its Che-SD thermal probe, which recorded temperature changes with depth. At the surface, the readings were scorching, nearly 60 degrees under the harsh lunar sun. But just 8 centimetres down, the temperature dropped to 10 degrees. That's a difference of 70 degrees in less than the width of your hand. What this tells us is remarkable. The lunar soil, the regolith, is an extremely poor conductor of heat. The surface burns in sunlight, but the layers beneath stay cold, even during the long lunar day. And if they stay cold, that might be where the water hides, not exposed on the surface, but buried just below it, trapped in the cold layers of soil beyond the reach of sunlight. It's not that Chandrayaan-3 failed to find water. It may simply have been looking a few centimetres too shallow. The Chandrayaan-3 mission lasted only 2 weeks, barely a heartbeat compared to decades of lunar exploration, yet its impact will endure far longer. It proved that a low-cost mission can make world-class discoveries. It showed that India's scientists, working with precision and imagination, could accomplish something that once belonged only to superpowers. And most importantly, it gave us vital clues about where to look next. Future missions, armed with drills and thermal sensors, will dig deeper beneath the dust where sunlight never reaches. If we're ever to build a base on the moon, understanding how that hidden water moves, freezes, and melts will be essential. It won't just keep astronauts alive, it will fuel rockets, sustain life, and anchor humanity's next great step beyond Earth. So perhaps Chandrayaan-3 didn't fail at all. It simply reminded us that science rarely gives easy answers. Each discovery opens another question, and each mission takes us one step closer to understanding our place in the cosmos. Maybe the moon is still keeping some of its secrets not out of reluctance, but because it wants us to keep searching, because exploration isn't just about finding what we expect, it's about learning why we didn't. So yes, if you ever find yourself on the moon and want a drink of water, you might want to bring a shovel. In the stillness of the lunar night, the lander and rover now rest silent monuments to human curiosity. They did not find the frozen lakes we imagined, but in their absence they revealed something deeper, that discovery is rarely a straight line. Sometimes the answers we seek lie just below the surface, hidden, waiting for us to look again. Chandrayaan-3 may have lasted only 14 days, but in that brief time it extended the reach of an entire nation and reminded the world that wonder has no borders. The moon still keeps its secrets, but thanks to those who dare to ask, we are closer than ever to uncovering them. I'm your guide, and this is Cosmic Compass, where we follow the light wherever it leads.